Welcome to Pavithra Laptop Care. So today we come to know about the charging IC, facts, what are the facts and some tricks. Okay. Some technicians put the command all voltages and all high low MOSFETs everything is fine, but then also battery is not charging. What could be the reason? It will be many reason. First they have to understand in advanced level, then only easily they can identify the problem. Okay, so first basic steps, what are the steps you have to follow, those things I will explain today, and I will ask some questions to advanced level technicians. Okay, so I will ask in between. First thing is, what is charging IC, what it does? What is charging IC? Any answer? Any guess? No? Simply they will put charging IC and battery will charge. No. See, in previous video I already explained about SM bus and SPI. The charging IC is a part of SM bus communication component. Okay. I clearly explained in SM bus case, a master and a slave will be there. See, in this who is master? EC, embedded controller, is the master and slave is charging IC. Okay, this is the fact. Okay, IC is a SM bus controlled slave component, not master. What EC will tell, that thing it will work. I mean that command it has to follow. Okay, that's work is for charging IC. This is a very important note. Okay, so one more secret I will tell. All charging IC, all compatible charging IC are not suitable in some cases. For example, BQ 24735 and 725A, both pin configuration will be same, but functionality will be little bit different. These things you should be note down, then only you put the charging IC. If pins are equal, that is a not point to connect one more IC, I mean a compatible IC. In the board what IC is there, same IC you have to replace it instead of compatible IC. Because many cases I have seen, so compatible IC always is not good, so go for the accurate one which is come from the board or is there in the schematic. Okay, this is also one point, please note down. Now I'll come to the point, means what is charging IC. Charging IC is a slave component to do the SM bus functionality. Okay, SM bus, what it is? System management bus. Directly it will charge the battery. Okay, a charging IC is a part of SM bus to charge the battery. This thing is the basic foundation thing, so this point you have to be note down. Second thing is, see, for example I will take 735 IC. It's a BQ 24735. It's Texas Instruments as manufactured. In any charging IC, what we will do, we'll put two MOSFETs, first and second MOSFETs. Then a CLR will connect and one more MOSFET, discharging MOSFET we will call. That also connected to the charging IC. and then through the phase, through the buck converter MOSFETs, here CLR, one more CLR will be there, battery connection will be there. Right, this is the diagram of common charging IC. So one thing is, here is a resistor, right? What resistor? Current sensing resistor. Why we call current sensing resistor? Here in this particular resistor, through this resistor only we set the current limit. Set the current limit. Okay. Here also we set the current limit for battery. So that's why it's a current sensing resistor. Okay. Here for advanced level students, I have a question. Okay, please listen carefully. I have a question. This charging IC as connected to this particular CLR, right? Here what will be the value of this CLR? Some people directly they put the jumper because it has low impedance. Your battery won't charge. Okay. Here also they put the jumper. Your battery won't charge. In what are the cases your battery will charge? The condition of the battery sensing. See, as I told, this resistor is a current sensing resistor. Please note down, this is the current sensing resistor. We are limiting the current. This BQ735 IC, it gives the what is the current minimum, for example 120 milliamps to 8.14 amp. See, it provides the current 120 milliamps to 8.14 maximum, I am telling, to charge the battery. Okay, this functionality or capability this particular IC has. All components are good. Okay, in that case also battery won't charge. Here is a solution. See, first you come to know what it is and what the value you have to use. Usually we will use what value? 10 milliohms. 10 milliohms, not 10 ohms, 10 milliohms. Right. You should use this one, and other than this, maximum for advanced level questions, I mean advanced level technicians I am asking, maximum what value we can use this current sensing resistor. Please put it in comment if you know the answer, exact answer. Okay, I won't tell now what will be the maximum one. So one more point you have to note down. Here two resistors will be, two what will be there? Capacitors will be there for positive side and negative side, right? So this capacitor having equal value. Okay, what is that? 0.1 microfarad. Here also 0.1 microfarad. If we use more than this 0.1 microfarad, will the battery charge? Please listen carefully. Once again I am asking, if instead of this 0.1 microfarad capacitor value, if we use more than this, will your battery charge? One is for this resistor and second one is for this capacitors. And here also for differential voltage, to get the differential voltage, difference between this positive and negative voltage, one more 0.1 microfarad capacitor we have to use, which should not be grounded. Okay, careful, this which should not be grounded, and differential voltage it has to get, okay, between this positive and negative. These points you have to note down, then only you can solve the problems. See, battery capability voltage is 1.024 volts to 19.2 volts. This is the maximum charging level of this particular charging IC. Please note down, it's 1.024 volts to 19.2 volts. This is the maximum charging capacity. Okay, it gives the output of this. You got my point, right? So according to this particular charging IC, what is the current sensing of this particular circuit, that we have to note down. Okay, that also a major point. If the particular values is not good, then also it won't allow the charge the battery, or it won't give the phase. Understood? And one more point is I lim. It's a current limited. It's a secondary protection. We call it as a secondary protection. This also having some particular values. It won't cross the voltages. Always less in millivolts. In millivolts you will get the value. Okay. Here also one important note. This, what is that? Pin configuration, what are the component it has connected, those things also you have to keep it in your mind. Those things also you have to check. These two things. First thing is primary is this current sensing resistor and capacitors you need to check. Second thing is ILIM connectivity components you have to check. Here is the first clue I have given in this video, and next videos, next voltage limitation of this particular charging ICs will start. If you are interested, very much interested to know about this charging IC, please comment me what are the answers for this sensing resistor capacity, what will be the maximum value, and this capacitor values. And one more question to them. Here is the discharge MOSFET. Here is the discharge MOSFET. Just think about this. Discharging MOSFET for what purpose? Here 19 voltage, here battery voltage 12 volts for example will be there. Okay. Here 19, here 12. Here opposite will be there. So voltage won't cross here. Until unless it will be on condition. Okay, it must be off condition because voltage should not pass. Here is a question: if I remove this discharging MOSFET, will the battery charge? Once again I will repeat, if I remove the MOSFET, discharging MOSFET, will the battery charge? Okay, these three questions I asked here. Who are interested? So personally you can do the Telegram or in WhatsApp also you can send your answers, or you can put in comment box. Okay. Thank you very much.